Hey, welcome back. Today we're going to be finishing up our notes on summary statistics. Okay, what I want to point out here today about standard deviation before we go on is that if we were taking the standard deviation of a population, that would mean every single person, let's say I'd have to do the survey, say I was doing a statistics off a survey here at East Noble. If I was doing the population, then I'd have to do every single student of the entire school. All right, so this would be like every student. If I wanted to do a sample, right, then I could do maybe the one class. All right, we just pick one class out of the entire school and we give them the survey and we see how that turns out. Well, how does that affect our data? Well, to do a standard deviation, then, if we're doing it for the entire population, we divide by the n. But if we were doing it by a sample, let's say just the class, we would take the number of people in the class and subtract 1. That's really the only difference there is when it comes to standard deviation. Let's go over standard deviation here one more time today. I think it'll be a good review for you guys. These are my numbers: 2, 5, 8, 9. You know what? I'm going to put these in order, and you'll see why here in a second. I got 2, and let's put the 5s in place. So I got 3 more 5s. And then we've got a 6, an 8. Okay, what I've done here then is I've went ahead and filled in the rest of the table. I put them all in order so they're side by side, and then the mu. So the next step then is to take each number and subtract the mu from it. Well, 2 minus 6 is negative 4. 5 minus 6 is negative 1. That means all of these here are negative as 1 as well. 6 minus 6 is 0. 8 minus 6 is 2. 9 minus 6 is 3, which means the last one is 3 as well. And that's why I put them in order, so that I can see that very easily. The next thing I know how to do now, the last step here then, is to square each of these. All right, so 4 squared is 16. 1 squared is 1, 1, 1, 1. 0 squared is 0. 2 squared is 4. 3 squared is 9. 3 squared is 9. My last step then is to add all these up. Well, not quite my last step. I need to add these up. All right, I've done that. Now I need to divide it. So I'm going to do the bottom, divide by this total population. 42 divided by 9. Notice that I also rounded it to one number more than what we originally had. The last step is to take the square root. And then that gives me then a standard deviation that's equal to 2.2. Okay, then with our histogram, let's talk about some new data here. A histogram is a common data distribution chart that is used to show the frequency within specific values or values within ranges that occur in a set of data. An engineer might use a histogram to show the variation of a dimension that exists amongst a group of parts that are intended to be identical. So you can see there's a bunch of variation here. They had, let's say, 4 parts that were 0.750. They had, let's go right here, they had at 0.748. 3 of them came in at 0.748. Well, all of them are supposed to be the exact same length. Histogram. Histograms' large sets of data are often divided into limited number of groups. These groups are called class intervals. All right. Here's a histogram. The number of data elements in each class interval is shown by the frequency, which is indicated along the y-axis of the graph. So we're going to have frequency over here, and this is the range of values that it could be. Here's an example of this histogram. They've separated it from 0.5 to 5.5 to 10.5 to 15.5. Now we've got these values up here. I don't know exactly why they're all spread out like this, but between 0.5 and 5.5 there are 1, 2, 3, 4, 5, 6 that fall in that range. All right, between 0.5 and 5. So I would actually want to go up here to about 6. Then between 5.5 and 10.5, with a different color here, there are 1, 2, 3, 4, 5, 6, 7, 8. 8 of these that would fall in this range, so I would need to go even higher. And then the last one, there are 1, 2, 3, 4. So I would go with my frequency table here to 4. And this would now be my frequency table. Okay, here's a dot plot. A dot plot's a pretty simple thing. You just simply take the data, and for every piece of data, we just simply pile them on top of each other. And for example, there was only one -4 on all of this, so that one -4 went there. There are 1, 2, 3, 4, 5, 6 zeros. So there's 1, 2, 3, 4, 5, 6 dots on 0, so forth. Let's just take a look at, for example, there are no 5s in here at all, so there are no dots on top of the 5. So this is a dot plot. Pretty simple graph. After you have your dot plot, you can very easily turn this into a histogram by drawing in the boxes that would represent each set of data. Right? And there's nothing wrong with you guys doing a dot plot and then turning it into a histogram if that's simpler for you. Okay, let's talk about what's a normal distribution of data. When we have a normal distribution of data, we should get this nice bell-shaped curve right here. Right? And this is what we call this bell-shaped curve. This is a nice normal. This is what we like to see when we have our normal distribution. The empirical rule. Well, this applies to normal distributions. Almost all data will fall within 3 standard deviations of the mean. All right, what this means now is we're taking what we've learned about standard deviation and we're going to apply it to the mean. Well, here's our empirical rule, and this is important. All right, this right here being our mean. Everything that's in this red region, all right, is 1 standard deviation away. So what they did is they took the mean and added a standard deviation. They took the mean and subtracted a standard deviation. Here's what you guys need to know. 68% of the observations fall within 1 standard deviation. All right. The green, all right, 95% of your data is going to fall within 2 standard deviations. All right, so that what we're talking about here is all the way from this edge to this edge. If you take all that area, that's 95% of the data there. All of the data, or 95% of all of the data, is going to fall within 2 standard deviations. And then the last one here, 99.7% is going to fall within from one blue marking all the way to the other blue marking. Not all of it. There's going to be some things we call outliers, which might end up out here somewhere, but 99% of the data should fall within 3 standard deviations. If it does, then we call this a normal distribution. All right? So an example of this, all right? The mean of all this data was 0.08. 1 standard deviation was 1.77. So what they're saying here now is we should be 1 standard deviation of that. This right here mark is going to be 0.08 plus 1.77. This mark over here is going to be 0.08 minus 1.77. Right? Then 2 standard deviations. Oh, sorry. A normal 68% of the data should fall within that range. All right, 68% of the data should fall within that area. We still have all this stuff out here. Probably 32% of it's not falling within 1 standard deviation. The next one then is 2 standard deviations. So the way they got these numbers is they took 0.08 and added to it 2 times the standard deviation of 1.77. Over here they took 0.08 and subtracted 2 times 1.77. And this right here gave us 2 standard deviations from the middle. And that would be 95%. And that's how we find how we do our normal distribution. Well, hey, I hope that was beneficial for you guys. I'll catch you on the flip side.